Hey guys, I just wanted to help you out on day 20 a little bit on the homework. I did want to notate that I did find the mistake in the print. So on your day 20 homework, number 17 actually has a mistake on it. So if you guys remember, I actually told you, hey, there's a mistake on this, but I don't know where it is. Well, number 17 is where the mistake is. So number 17 should be R. Yes, I understand it does not equal 2 secant squared x minus 1. So, please, I'm sorry, I forget every year that when I use this sheet that number 17 has a mistake. But since you usually don't solve that one till the end, you can figure out that it says the North Pole on the bottom. Alright, now I did get a request to go over number 3, 13, and number 5. So I'm going to go ahead and do those for you. And then just make sure that you guys hold on to it to study for your quiz tomorrow, actually, for you. Okay? All right. So the first one I want to do is number 3 from your homework. And number 3 is sine x plus cosine x and cosecant x plus secant x. All right. So obviously we're going to have to multiply here. So I'm going to distribute the sine first. I get sine x cosecant x plus sine x secant x, and then do the cosine. I get cosine x cosecant x and cosine x secant x. Alright, so sine and cosecant x gives us 1. So I'm going to change that to 1. And cosecant and secant is also 1. Alright, and then in the middle, I don't know what to do with that yet. So let's rewrite it. We have sine x secant x. And we have cosine x cosecant x. Alright, so 1 plus 1 is 2. So let's write that as 2. And I'm going to go ahead and change all of these to sines and cosines and combine them. So this becomes 1 over cosine, and this one becomes 1 over sine. Alright, so I have 2 over 1 plus a sine over cosine plus a cosine over sine. So now this is looking a lot like our day 19 homework where you guys had 3 fractions and you had to find a common denominator. So the 1 here is missing a cosine and a sine. So I'm going to have to multiply the 2 by cosine and sine. And the cosine is missing a sine, and then the sine is missing a cosine. So my common denominator in this case is sine cosine. Alright, so I'm going to multiply the 2 by sine cosine. That's the easy one. I just rewrite it. I got to multiply this one by sine. So that's sine squared over sine cosine. And I got to multiply this one by cosine. So that's cosine squared over sine cosine. Alright, so now that I have a common denominator, I can, combine all of my numerators. So we have 2 sine cosine plus sine squared, plus cosine squared, all over, nasty square there, sine x cosine x. Alright, so I actually see an identity staring at us right in the face here. So sine squared plus cosine squared is 1, right? So let's change that to a 1. So we have 2 sine x cosine x plus 1 all over sine x cosine x. Alright, so this doesn't happen very often, but this is why I had a request to do this one. Because I actually have to separate this back into 2 separate fractions. So if I write this as 2 sine x cosine x over sine x cosine x, and I write this part as 1 over sine x cosine x, Now, as you see, these cancel out. Leaves me with 2. And here, see how it says 1 over sine and 1 over cosine? Well, 1 over sine is cosecant, and 1 over cosine is secant. So if I'm looking at the paper, it looks like if I just flip the secant and the cosecant, I will have the letter A. Alright, the other request was number 5. And once I show you number 5, number 6 is actually set up very similar. It's actually easier than number 5. My biggest annoyance with number 5 is that I get a lot of students that will tell me that this is cosine squared x, because they subtract the sine squared and the sine squared here. Please remember PEMDAS. These are being multiplied, so they have to be multiplied together before I can add or subtract. So you can't just start subtracting things. That doesn't work. But I do see that both of my terms have a sine squared. So this means that I can do a GCF. Alright, so I have a GCF of sine squared, so I'm going to write that on the outside. And it leaves me with cosine squared x for this term, because, you know, that one was divided out. And this one, when I divide it by itself, leaves me with a minus 1. So this is why I wanted to do number 5, because this part here causes an issue. Because if you go and you look at our identity says that sine squared x plus cosine squared x is 1. So if I subtract cosine from both sides, I get 1 minus cosine squared x. Well, the issue is that in this one, the cosine is positive and the 1 is negative. But on our proof, our identity, the 1 is positive and the cosine is negative. So remember when I told you guys that sometimes you'll have to multiply everything by negative? So if I multiply both sides of my Pythagorean identity by negative, I get negative sine squared x is equal to a negative 1 plus cosine squared x. And if I flip that around, I get cosine squared x minus 1. So instead of replacing this part with a sine squared x, I have to replace it with a negative sine squared x. And then a negative times a positive is a negative. Sine squared times sine squared is sine to the 4th power. And so this answer is S. S for sine. Alright, last one is number 13. Alright, 13 is actually really short. So it's sine x minus cosine x, sine x plus cosine x, all over sine squared x minus 1 over secant squared x. Alright, numerator. I notice right away that I have the same thing, but with rotating signs. That's a difference of 2 perfect squares, you guys. So this means that if I multiply them together, I'm going to get sine squared minus cosine squared. And the denominator, this, remember how I said that 1 over secant is the same as cosine? That was one of the new basic identities I pointed out to you guys. So 1 over secant squared is cosine squared. So I write sine squared x minus cosine squared x. Oh my gosh, it's exactly the same thing, so it's 1. I believe the number 1 on this is O. So that is our answer, O. Okay? Alright, so hopefully these 3 problems helped you out. Like I said, go ahead and hold on to day 20. You can turn it in tomorrow, and I will answer a couple more questions over day 20 before you guys take your quiz.